In section 1.2, we'll be talking about functions. Before we can talk about functions, we've got to identify a few things here first that is going to help us understand better what a function is and what it is not. All right, so first thing up here that we have is a blank is a set of ordered pairs. So sometimes in math we call this a relation, or sometimes we call it a correspondence. So I'll put that underneath here too. Okay. Is just a set of ordered pairs. So the first component in that ordered pair is called the domain, and the second component of the ordered pair is called the range. So now we can get to talking about what a function is, right? So a function is a relation in which for every value of the first component of the ordered pair, there is exactly one value of the second component. Each member of the domain corresponds to exactly one member of the range. Okay? So one thing to keep in mind here, the idea of function is not a difficult thing, but it's easy to get it kind of mixed up in your mind. So one thing that I want to point out here, with a function, the x values will not repeat. Okay, so that is an important thing to remember. And when we're talking about an ordered pair, like x and y, all right, the x is the domain, so all of the x's that we have are the domain, and all of the y's are the range. Okay? So sometimes we can have a point that we're determining domain and range of, but sometimes we have graphs that we're looking at, tables. There's different ways that we will look at this domain and range. Okay? All right, I want to give a little analogy to help you remember about functions. And so one thing that I like to use is about a vending machine. So I'm going to just name some things that might be found in a vending machine. So I love Twix, so let's put that in. All right, chips might be another thing that we find there. Maybe a cookie and M&Ms. All right, so these are some things that we can see in a vending machine. Well, how do we determine, or how does the machine know what we want? Well, there's little buttons that correspond with it. All right, so I'm just gonna name some buttons here. And we can see that when we click on A1, out comes a Twix. If we click B2, out comes chips. C1, we get a cookie, and D4, we get M&Ms. All right? And so this is a function because when we press that button, we know exactly what we're going to get. And notice how the first values here, right, are all unique. And so that is helping us understand that it is a function also. So I'm going to put that underneath here. This is a function. However, if in a vending machine, say that we have A1 button goes to Twix, and then they messed it up and they put another A1 in there, and that's chips. Well, that would be a problem because when we click on A1, we don't know what we're going to get. All right, now we could have other things in here too, like our cookie and stuff, right? But the thing that we need to remember is that those values there, these can't repeat. We can't have the same button. So that would be not a function, because when we click on the button, we don't know what we're going to get. Okay? Another thing to maybe keep in mind here is that sometimes you've probably seen some vending machines just that are full of water. That's all they have in it. So if you click A1, you're going to get water. If you click B1, you're going to get water. If you click C1, you're going to get water, and so on. All right? And this is a function also. Right? It doesn't matter that the second component here is repeated, right? These waters. It's the thing that we're looking at is if they have a different button for each one. All right, so this would be considered a function. So again, going back up to what we said here, no x values can repeat. If the y values repeat, that's fine. It's still a function. Okay, so hopefully that helps you keep that in mind to understand what a function is and what it isn't. All right, so on this next one, determine if the correspondence represents a function. Well, we see here we're talking about the age of a baby in months, and then the average daily weight gain in grams. So it's saying a 2-month-old on average will gain 21.8 grams. At 9 months, the average daily weight gain is 11.7, and so on. All right, so we're trying to determine if this is a function or not. Well, when we look over here, we see that all of these months are unique. We wouldn't have something here where it says month 2 has an average of 21.8, and then maybe, another 2 that says a different value. Because at month 2, the average daily weight is going to be the same. So this is a function. Okay. Let's see, on this second one, you can see A go to 2, B go to 2, D go to 3, G goes to 4, and H goes to 4. And sometimes people think that this isn't a function because like A and B are going to the same number. But again, remember we said we need those first components to be unique. And since they are, this is a function. But if we if we flip-flopped these and we had 2 going to A and to B, 3 going to D, 4 going to both G and H, well, if I was to click on 2, I don't know whether I'm going to get A or B, right? So, and the same thing with 4. And so this would not be a function. Okay. All right, so hopefully that is clear on what a function is and what it isn't. So here we've got some correspondence below, but we're also going to identify the domain and range on these. So if we look at this correspondence, we are saying, okay, our domain has the numbers. Those are the x values. So 3, 9, 12. Those are all our domain in the set of our domain. And then our y values are a range, so that would be 5, 8, and 10. And since none of those x values repeated themselves, this is a function. And then we can do the same thing for these other ones. Let's just look at this one here. So I can see that my domain is 0. And then I've got 1, a -1, and -1. And that is repeated. We don't need to repeat it down here when we're listing the domain and range, but we do need to identify those are repeated. And since the x value is repeated, that means this is not a function. Okay. But we do want to list our range there as well. So our range, we have 3 and 2, right? 3 is repeated. It doesn't matter that 3 is repeated. That's not what's making it not a function. It's that the x value is repeated. So we've got 2 and 3 are in our range. All right, and I'll leave those other two for you to work on your own to see if you can figure those out. All right, so we also need to talk about something called function notation, right? So we said earlier that a function is a rule that assigns exactly one range value to each domain value. And they can be described by an equation that tells how the x variable and the y variable are related. Now, we write, so y is the same thing as f of x. Right? So sometimes you'll see that we have equations and they have y equals something like this one down here. Y equals this. Well, to make that into a function, if we know it's a function, we can use this f of x. So this, right, it reads as y equals f of x. All right, now notice this doesn't mean times. This isn't saying f times x. It's f of x. So it is the value, of this f function. When we put x in, we're trying to figure out what comes out. All right, so let's do that down here. And I'll just do it on this first one, and then I'll leave the other two for you to do. So first, let's write it in function notation. So that means we need to change that y to f of x. Right? And you can't use function notation like this if it's not a function. So sometimes I get from students, well, why do we care? Why do we care if an equation is written with an f of x instead of a y? Well, it's telling us specifically it is a function. Right? And there's certain things that we can do with functions that we're going to talk about later. So if we put this, so 6 over x minus 3, right? And so then it says find f of 2. So that means we're going to replace, right? We're going to put 2 everywhere we see an x. So in this one, I have 6 over 2 minus 3, right? Notice I'm not multiplying by 2 anywhere. Okay, I just replaced it, and now I just need to simplify it. So I have 6 on the top, 2 minus 3 is negative 1, and 6 divided by negative 1 is negative 6. And what we just found actually is an ordered pair that is a point on this graph. So I also want you to write down this ordered pair. So we said when x was 2, all right, we would get negative 6 is our f of x, but in this case, we're going to think of it as the y since we're thinking of it as the ordered pair. Right? So that would be our ordered pair, a point that would be on the graph of this equation. Okay, and I'll leave B and C for you to complete on your own. Let's go to this next one. And again, same kind of thing. And I want to just show you a couple of things here to be careful about. So this says just find f of negative 3. But notice how we have different names of functions here. So I've got a g of x, I've got an h of x, I've got an f of x. So it's not just that. We're going to find g of negative 3 and also h of negative 3. Okay. And so on this first one, we're going to find g of negative 3. So that means that we're going to put negative 3 anywhere we see an x. So I've got 2. When I take out that x and put that number in place of it, take it out and then put that number in parentheses because it'll be more accurate and you won't make maybe some mistakes with negatives. All right, and then to simplify this, we need to think about the order of operations. Well, I need to do exponents before I do multiplication. So let's go ahead and take -3 and raise it to the second power. So I've got 2 times 9 plus 5. And now I do multiplication before addition. So I've got 18 plus 5. And when I combine those together, I get 23. So again, we could write this down as an ordered pair as a point on that, the graph of that line, which would be our x was -3 and our y is 23. All right, I also want to do this one because I want to talk about this absolute value and just to be really careful on this. So if I ask you to find f of -3, let's go ahead and do like we did before and just replace that x that we have with a -3. All right, now be careful with these absolute value bars. All right, these are grouping symbols, and so we need to treat it like parentheses in our order of operations. So we're going to start inside here first. And so I can see that I have multiplication and I have subtraction. Well, I've got to do that multiplication first. So I'm going to write down this first part here. -5 minus 3. And I'm going to put this little multiplication dot here just to help you remember that it's saying this -3 is going to be multiplied by the absolute value. And let's get this simplified a little bit more. -5 times -3 is positive 15 minus 5. All right, and keep those absolute value bars there. We haven't done those yet. And be really careful. A lot of people want to try and do -5 minus 3, but you can't do that yet. We have to do our multiplication before we can do our subtraction. So make sure you leave this here. But let's go ahead and finish simplifying this. 15 minus 5 is 10. So we've got the absolute value of 10. And the absolute value of 10 is just 10. So I have -5 minus 3. And now I'm going to put it in parentheses because I found the absolute value of 10 to be 10. Now I need to do my multiplication first there. So -5 minus 30, and -5 minus 30 is -35. And again, we could write this as an ordered pair being 3 comma -35. Okay. All right, and I'll leave you that B one there to do on your own. Okay, when we're looking at graphs, it's easier to use what we call a vertical line test to figure out if something is a function or not. So looking at this, just to make sure it's clear what we mean by the vertical line test, if I put a vertical line anywhere along that graph, like, I'm looking to see if it crosses that graph more than once. If it crosses it more than once, it is not a function. If it only can cross it in one place, then it is a function. So we can see on this one, this vertical line test, we can see that it fails it. So this is not a function. Okay, similarly, with this circle, well, if we draw a vertical line anywhere along there, we can see it is going to hit in 2 places again. So again, this is not a function. Now in this one, anywhere we put a vertical line, we'll see it's only going to cross that at one place. There's no place along here we can put a vertical line where it will hit more than once. So this one is a function. All right, and then this last one, sometimes people kind of look at it and go, I'm not quite sure on that. But if you look closely, you can see that we've got some open circles there on this graph here. All right, we've got an open circle there and an open circle there. So when we're thinking about the vertical line test, well, it's hitting -2 on this one, but this is an open circle, so it's not hitting there. Right? So it does pass the vertical line test on this one as well. So this one is also a function. Okay. All right, so now let's do this again. Let's see if, if these guys are functions, and then let's also give the domain and range, and we're going to write these in interval notation. If you are struggling with interval notation, it doesn't maybe look familiar to you, make sure you go and watch another video about interval notation. Okay, so we're looking at this one and we can see that yes, this is a function. It passes the vertical line test. Now our domain is when we're looking at the graph from left to right. I'm going to write this down up here. All right, so the domain, we're going to look at graph from left to right. And then I'll put range here. For range, we're going to look at the graph from bottom to top. So it's important to know how to determine these, the domain and range, by looking at a graph. So the domain, you can see we're looking at it from left to right. So the furthest left this goes over, right? Sometimes on some of the graphs they don't have little arrows, but if it doesn't have like an end point like this one does, then that means that there should be an arrow there, and it keeps going off of the graph that we can see here. And so this is going out to negative infinity. That's the furthest left it's going. And then the furthest right is right here at 3. Okay, so my domain, I'm just going to kind of go, all right, so you can kind of see here, this is what we're looking at for the domain. So writing that down, whenever we're talking, when we're putting things in interval notation and we're using infinity or negative infinity, it's always going to have a parenthesis next to it. Infinity is not a number we can get to, and the square bracket means that it includes that value. So that wouldn't make sense for infinity or negative infinity. Okay, but then we can see that the furthest right it goes is 3, and it does include it. So let's put that square bracket to say it is this closed circle here, that it is part of it. And then the range, we're going to look at from bottom to top. All right, so we're going to start here. We can see, maybe I'll go over here. All right, that's the lowest the graph is. And then we're going to look going up, right? From bottom to top is how we need to write this. And this is our range. All right, so our range, the very bottom of it is 0, and it includes it. So we'll put square bracket 0, and then remember this is going up and out forever. So it is going to go up to positive infinity, and so we need a parenthesis after that as well. All right, and I think I will leave that other one for you to do, as well as these two down here. Okay, so think about what these are as far as being able to do the domain and range. And if you need more help with interval notation, please find a YouTube video that will help you with that, or come talk to me.